Hey everyone, and welcome. Today we're tackling a Leetcode problem called Longest Unequal Adjacent Group Subsequence Part 1. Sounds a bit fancy, but don't worry, we'll break it all down, step by step, and make it super clear. Let's dive in. So here's the challenge. We're given a list of words, let's call it, and another list of numbers, called each word lines up with a group number, which can only be 0 or 1. Our mission is to pick out a sequence of these words, such that, if we look at any two words next to each other in our chosen sequence, their group numbers must be different. And of course, we want this sequence of words to be as long as possible. If there are many ways to get the longest sequence, any one of them is fine. Let's look at an example. Suppose our list is dark, and the list is 0, 0, 1, 1. We want to pick words so their groups alternate. If we pick the first, its group is 0. The next word is also, and its group is 0. Nope. Can't pick that next, because the groups are the same, not different. How about the first? Its group is 1. If our last picked word had group 0, and this one has group 1, that's perfect. So far we could have then, the last word is, and its group, is 1. Our last picked group was 1, so we can't pick this next, as the groups would be the same. So the longest sequence we found is, their groups are 0 and 1, which are different. That works. Let's try another one. The list is hertelum, and the list is 1, 0, 1, 1. First, let's pick its group is 1. Next, consider its group is 0. The previous group was 1, and this is 0. They're different. Great. Our sequence so far could be next, its group is 1. Our last picked group was 0. 0 and 1 are different. Awesome. Our sequence could be, next, its group is 1. Our last picked group was 1. Since these groups are the same, we can't add, so is our longest sequence. The groups are 1, then 0, then 1. All alternating. Okay, how should we approach this? Since we want the longest sequence, and the condition is just that adjacent groups must differ, maybe we can just try to build it step by step. We could start with the first word, and then look for the next word in the original list, whose group is different from our last picked word's group. Then, from that word, look for the next one after it with a different group, and so on. This feels like it could work, because we're always trying to extend our sequence as soon as we find a valid word, and the problem says any longer sequence is fine. So the idea is pretty straightforward, often called a approach. We make the choice that looks best at each moment. First, we'll definitely include the very first word in our result list. We have to start somewhere, right? Then, we'll look at the second word. If its group is different from the first word's group, fantastic. We add this second word to our result list. If its group is the same, we skip it and look at the third word. If its group is different from the group of the last word we actually added to our result list, we add this third word. We just keep doing this, always comparing the current word's group with the group of the very last word we decided to keep. If they're different, we keep the current word. This way, we're always building an alternating sequence. And since we check every word in order, we're trying to make it as long as possible. Alright, here's how that greedy idea looks in Python code. It might seem like a bit at first glance, but no worries, we'll walk through it nice and easy. The core idea is exactly what we just talked about. Pick the first one, then pick the next one that alternates, and so on. Okay, let's look at the beginning. First, we create an empty list called result subsequence. This is where we'll store the words we choose. Then, a quick check. If the input list is empty, well, there's nothing to do, so we just return an empty list. Assuming we have words, we always add the very first word, that's the word at index 0 from the input list, to our result subsequence list. And we remember its group, storing it in a variable called last added group value. This last added group value will help us decide which word to pick next. Next up is the main part, a loop. This loop starts from the second word in our input list, that's the word at index 1, and goes all the way to the end of the list. For each word, we look at its group. Let's call it current group value. We then compare this current group value with the last added group value. That's the group of the latest word we added to our result subsequence list. If these two group values are not equal, it means we have an alternation. So we add the current word, the one at the current index, to our result subsequence list. And, very importantly, we update our last added group value to be the group of this new word we just added. This way, for the next word we check, we're comparing against this newest group. Finally, After checking all the words, we return our completed result subsequence list. So how efficient is this approach? Pretty good. For time, we basically go through the list of words just once. So, if there are words, the time it takes is proportional to, we call this big O of n, or order n time. That's nice and linear, meaning it's quite fast. For space, the list we build for the result could, in the best case for length, store all words if they all alternate. But the additional space our algorithm uses for its own bookkeeping, like remembering the last group value, is very small, just a couple of variables. We call this big O of 1, or constant extra space, which is excellent for memory. Alright, to sum it all up, we needed the longest sequence of words where their associated group numbers alternated. We found that a simple greedy strategy works perfectly. Start with the first word, then just iterate through the rest. If a word's group is different from the last one we picked, we add it to our sequence. This method is beautifully simple and also very efficient. It runs in order n time, where n is the number of words, and uses order 1 extra space. Easy peasy. Hope that breakdown made the problem clear and the solution easy to understand. If this helped you out, please hit that like button, consider subscribing for more Leetcode explanations, and feel free to drop any questions or thoughts in the comments below. And hey, if you're feeling extra generous, you know where to find the Boba Fund. Keep practicing, keep coding, and I'll catch you in the next one. Bye for now.